Chords, inscribed angles, and triangles. Click on the link below and complete the labs before the chords lesson. The arc of the chord is the arc that shares the same endpoints with a chord of a circle. So arc PQ is the arc of line segment PQ. Recall, a chord is a line segment whose endpoints lie on a circle. Arcs and chords theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their chords are congruent. So arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. Proof of the Arcs-Chords theorem. Alright, the theorem again states, in the same circle or in congruent circles, two minor arcs are congruent if their chords are congruent. So given circle O, we know that segment AB is congruent to segment CD. We want to prove that arc AB is congruent to arc CD. Alright, so we begin with our given information. These two segments there in green are congruent. We also know that all of these segments are congruent. AO, BO, CO, and DO, because all radii of a circle are congruent. Therefore, we know that these are all congruent to each other, like that. So we have side, side, side triangle congruence. So we know those triangles here, this triangle here is congruent to this triangle here. Therefore, these angles, right, BOA, so this angle is congruent to this angle because corresponding parts of congruent triangles are congruent. Therefore, the arcs are congruent to each other because that's the definition of congruent arcs. Proof of the Arcs-Chords theorem, part 2. In the same circle or in congruent circles, two chords are congruent if their minor arcs are congruent. So given circle O and the fact that these two arcs, arc AB and arc CD, are congruent, prove that these chords are congruent. So we begin with our given information. The second step, angle BOA, the measure of angle BOA is equal to the measure of angle COD, y. Alright, and so since the measure of this angle is equal to the measure of this angle, we know that those angles are congruent to each other. For what reason? These angles are therefore congruent due to the definition of congruent angles. Alright, our next step is knowing that all of these segments are congruent. So AO is congruent to BO, which is congruent to CO, which is congruent to DO, because so these segments are all congruent to each other because all radii are congruent. The next step is that these two triangles here are congruent to each other. For what reason? The triangles are congruent due to SSS triangle congruence, because that's side, 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 and we have three pairs of corresponding sides. Therefore, line segment AB, chord AB, is congruent to chord CD because chord AB is congruent to chord CD because corresponding parts of congruent triangles are congruent. In summary, we have the theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their chords are congruent. Arc AB is congruent to arc CD if and only if chord AB is congruent to chord CD. Bisecting an arc. Definition. A bisector of an arc is a line, segment, or ray that intersects an arc at its midpoint. Hence, a bisector of an arc dissects an arc into congruent arcs. So given circle C and CY bisects arc XZ, we have that XY, this arc here, is congruent to YZ, this arc here, because that's the definition of an arc bisector. And we also know that Y is the midpoint of arc XZ because that is the definition of an arc bisector. Chord bisector theorem. If a diameter or radius of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So given that CS, this green segment here, is the diameter of circle O, then also given that CS is perpendicular to AE, the purple segment, prove that XE, this segment here, is congruent to XA, and AS, this arc here, is congruent to ES. Alright, so here's the proof of the chord bisector theorem. Given CS is the diameter of circle O and CS is perpendicular to AE, prove that this segment here, XE, is congruent to XA, and this arc here, AS, is congruent to arc ES. So we begin with our given information. Step 2, draw radii. So from the point O, we're going to draw OE and OA. So we're going to draw in these gray lines here. That is the line postulate.